I've been waiting for 3.5 hours now. I've learned a lot, but I really can't wait to tell you what I have to tell. Share my news.
I think we are all dying to see what you have to share with everyone. So let's jump straight into it, shall we?
Okay, let's go into it. So greetings from the team that has been working behind that red door, the super secret team. So we have indeed been working on a new product. So the big announcement here is that we are coming up with a new product, which is really aimed for private cellular design. Was that a complete surprise, or did we give some hints during the presentation maybe today?
Yeah,
I wonder.
There was a few hints that went out. I wonder if people could guess what was coming.
Right. Well, the team has been working very hard on that, and it's an amazing tool. But let me give you a bit of a background on that first. So, as you probably know, the private cellular has undergone a tremendous transformation and technical evolution over the past years, and that has made it a viable technology really for some selected enterprise use cases. So it has become simpler, and it has become in terms of complexity, and it has become much more affordable, and that's why it's a viable option nowadays. And also, as we heard from Matt McPherson earlier today, the IoT is growing exponentially, and the amount of devices to be connected is expected to explode. So there is definitely a need for easy-to-use design tool for other wireless technologies than Wi-Fi as well. So, as you know, Ekahau has been in the industry for 20 years. We are experts in RF design, and really our focus is in building easy-to-use, comprehensive tools that help our users to make great Wi-Fi designs so far. And now we want to take this experience and take this knowledge and basically transform also our products and our offering into this new exciting market. So should we take a closer look what it looks like?
Absolutely, yes. Let's take a look at what we have to offer there.
Yes, please click next.
Matt is a slow clicker.
Thank you, Matt. You're building up the excitement here. So our big promise is that if you can design a Wi-Fi network, you can also design private cellular radio network, or when it actually comes to that, also an IoT network. Now, that's a big promise. So what does it actually mean? So what we are saying here is that the basic design process in private cellular is very similar to Wi-Fi. First, you define your environment, then you define your requirements, then you place your radio network elements, and then you evaluate the compliance of your design or against the original requirements, right? This is the process. Now, there are some of the cellular KPIs have different names, like RSRP is an equivalent of a primary signal strength in Wi-Fi. Or signal to interference and noise ratio is pretty much close to SNR in Wi-Fi. And then data rate and throughput are the same. So that's the part that is very similar between Wi-Fi and cellular networks or private cellular networks. Now, the differences there are a few of them as well. Like, first of all, the sensitivity of 5G and LTE device antennas is much higher than in Wi-Fi. And therefore, you can actually build much larger coverage with smaller amount of radios in private cellular. And because of this, the design principles are also a little bit different. And this really depends on a bit on a vendor. So different vendors have different practices, but it's not uncommon to see that the design is actually started from a large space by placing a powerful unit or maybe a unit with a directional antenna that basically builds the basic coverage, and then smaller radios being added then to fill in the gaps. On the capacity planning side, it's also a little bit different because the private cellular is really designed for some specific use cases. And in those use cases, the devices have also their specific capacity needs. Like, for example, one of the use cases is to use high definition cameras to build coverage, for example, surveillance coverage to parking lots or large areas. And you know, high definition camera actually sends more data uplink than it actually downloads anything. So there's a specific need to plan the capacity in a way that actually more capacity is being provided for the uplink, and the private cellular provides actually the means to do that. Now, the radio network topology can be different. So as specified by 3GPP and Small Cell Forum and Open RAN, the radio network can be distributed into 3 different units. So central units, distributed units, and radio units to give more scalability on the radio side. Now, it doesn't have to be that. It's also possible that everything is located in a single unit. So in the same way than in Wi-Fi, you actually have your CU, DU, and RU and antenna in a single box. And now a little bit depending on that topology, then the cabling may be different. So especially in the distributed radio network architectures or topologies, the cabling is done using fiber. But then when you're talking about small cells, then the connection can be Cat cabling. And again, this depends on the requirements that you want to put on your front haul. Now, the spectrum usage is slightly different again. So in private cellular, there are no fixed channels. Instead, you can use the spectrum that is available, and you can allocate it in different chunks and different amounts to your radios. Like, for example, in CBRS, the total bandwidth is 150 megahertz, and that's by default divided into 10 megahertz chunks. But the designer can decide to allocate that differently if so needed. Also, it's possible to increase the capacity of the network by using a technology called carrier aggregation. So in that technology, you actually collect several small frequency areas together in a radio and use that to deliver the capacity that you need to your network. Then there are some spectrum usage technologies like time division and full frequency division duplex, TDD and FDD, but we are not going to go into that in this presentation. Now, one important point here to bring up is then the impact of the mobile networks outside, because it's possible that your private network is operating on the same frequency or very close by the frequency than the mobile network outside. So it is really important to analyze how much the outside network radiates inside of the building, and also the same way, how much does your private network radiate outside of the building in order to avoid collision and interference.
Hey, Antti, you've made this sound pretty simple and easy to, design for private cellular radio, but is that really the case?
You guys know me
it is,
too
because
well.
like, Antti, you've said that it uses the channel to put it into smaller chunks. That sounds like OFDMA to me. You said that the design process is similar. You said that you need to understand the existing RF inside the building. Of course we do. That's the same. So it really feels like it's quite similar, isn't it? So what is the main difference between the Wi-Fi and a cellular when it comes to the operation? How does it differ?
So you guys know me all too well. I did leave out a couple of small details. So maybe we take a deeper dive in a couple of important issues that need to be considered before even thinking of designing a cellular network, private cellular network. Can you please click next one? So the first topic I wanted to talk about is that when do you actually need to build a private cellular network? So although I mentioned earlier that nowadays, because of the technological evolution, the private cellular networks are cheaper and easier than they were before, they are not really that simple and that cheap. They always come with the cost. So they are not really intended, and they are not really suitable for building all kinds of wireless connectivity. They are really designed for specific use cases where you have specific needs that cannot be fulfilled with Wi-Fi. So for example, enhanced mobility or low latency or high security or extended coverage. And the devices that you typically connect via private cellular network are automated guided vehicles or robots or machinery or sensors or the earlier mentioned high definition cameras. So let's consider, for example, a logistics warehouse where you have hundreds or thousands of loading robots, each of one doing more than 100 pickups per hour, and they are going back and forth in the warehouse by themselves. In this kind of scenario, it is really important that the handovers are fast and they are reliable and they are fully controlled by the network. So this is a perfect use case for private cellular network, and it really justifies the investment into this technology. So who can then go ahead and build such a network? Basically, anyone can build it. There is no limitation on that, assuming that you have the spectrum and it's available for your use. And the added value of doing this is that it removes the dependency from the cellular providers. Two things: you can design and operate the network how you like, and you use your own practices. And second, and maybe even bigger thing, you avoid the monthly cost to your cellular providers because you're basically operating your own network. But just to make it clear, for any other wireless use case, Wi-Fi continues to provide superior capacity and throughput at unbeatable cost. You have several gigahertz of unlicensed frequency that can be used for Wi-Fi. And when we come a little bit later into how much spectrum is really available to be used for private cellular, there's a huge difference between Wi-Fi and private cellular. And as we all know, Wi-Fi can be also high performing and reliable when designed, right? So we are not really talking about swapping Wi-Fi with private cellular. I think we are just moving into hybrid world where we are going to have multiple different types of radio networks working on as an overlay networks on top of each other. So, okay, so how does it then look like? Let's look at the diagram on the right. So the first thing and the first major difference between Wi-Fi and private cellular is that in 5G, and I'm using now private 5G as an example, you need the services of the core network in order for the radio network to work, for the radio to work. So the core network contains the functionality to connect basically the applications, devices, users, and the services together. And many of the providers today are providing this functionality from the cloud. It can be either public cloud or it can be a private cloud. And all of this functionality is nowadays automated, so it gets deployed, configured, orchestrated automatically. It is beneficial, however, to have some part of the core network also located at the edge of the network. So basically on the premises, on the same location where you have your radio network, because this helps to avoid the unnecessary traffic to up and down to the cloud. Instead, you can route the traffic inside of the building. And you know, many providers actually even today offer this functionality in a quite compact form. It's basically a single server that you located right next to your switches and routers. Now, from that core server or from the edge onwards, it looks very similar to Wi-Fi. So you have your radio network, depending a bit on the topology, you have your cabling, and then radios are communicating wirelessly with the end user devices or with user equipment. Okay, so the point here is that, first of all, there needs to be a specific use case and need against which the entire network is being designed. Can you please move on to the next one? The second really important point is that spectrum is actually, there's a limited amount of spectrum, as we all know. And it's unlike in Wi-Fi, the availability and the cost of the spectrum can vary a lot. So first of all, the spectrum is available in 3 categories globally. So there are the unlicensed frequencies that we are using in Wi-Fi, 2.4, 5, and 6. And then there are the licensed frequencies that are used occupied by the mobile network operators. And then there's a third category called shared or lightly licensed frequencies that are open for public use or for private use. Now, currently the shared frequencies are the most obvious choice for building your cellular networks, but it's not the only option. So it's typically regulated country by country in a different way. So the best known example is the CBRS network in US, or CBRS frequency in USA, which is 3.5 gigahertz. but there are others, like, for example, 3.4 in Germany and UK, 3.46 gigahertz in France, and there are many others. This is just a list of few examples. So the access to this the spectrum is controlled by Spectrum Access System, which is called SAS, or the local regulator by some other means. And as mentioned earlier, there are a few examples of different frequencies here, but more options are being considered in many countries, and more of them are going to be opened in the near future. I'm sure of that. So in reality, we are talking about here mostly about the mid-band frequencies from 1 gigahertz to 6 gigahertz. So the low band here, meaning less than 1 gigahertz, there you have great coverage, a little bit less bandwidth, but this is really suitable for IoT communications. You know that many of the protocols already operate on either 450 or 900, and they are located here in the low band. Then we have on the right-hand side, we have the high band, also called millimeter waves. So frequencies above 24 gigahertz. And this is coming sometime in the future. This is not really present in too many places in the world today. So in reality, we are talking about here in the mid-band frequencies. And as you can see, it's pretty busy there. So in addition to the unlicensed bands, there are over 40 commercial LTE and mobile networks occupying the frequencies here and there between 1 and 6. And then in and between these commercial frequencies are also the shared bands. So how it works in practice is that, for example, if you're going to use CBRS as an example, how it works in practice is that any CBRS network needs to get an authorization from the SAS system before it can operate. And this authorization takes place frequently. Now, the 150 megahertz band, or the CBRS band, is divided into 3 categories. First, you have the incumbent category, which is occupied by the government offices and Navy. And then there's the primary category, which is basically these are the auctioned frequencies that you can buy, and the highest bidder wins it. And then there's a general access, which is then those are the frequencies that are free to use. So depending on where you are located, if you happen to be close to a naval base, or your neighbor wants to have a CBRS network too, you actually may get only some tens of megahertzes to be used for your private cellular network. Now, you may, of course, go and rent or lease those frequencies from the mobile network operators. They're nowadays happy to do that as well, but it always comes with the cost. It's no longer free. So that's an important consideration also taken into account before planning, starting to design the network, that how much of bandwidth I actually have, or how much spectrum I actually have, and can I really fulfill the capacity and the performance needs of my network by using this. All clear so far?
Super clear.
It cannot be any clearer.
That's good. So should we look at the demo? Enough talk. Let's look at how the tool looks like.
Now we're talking, man. So what we are about to see is something new that we have not seen before.
Absolutely. This is a global sneak preview just amongst us friends here. So you log in to the tool by using your Ekahau account, and you use the browser to do that. So this works in a very similar way than, for example, Ekahau Insights works already today. So once you're logged in and entered your credentials, it opens up the portal. And here you can see the different applications that we have in the portal. And now we are really interested in the cellular planner in the middle. So right now in this demo, I want to design a high-performance network to a warehouse using CBRS frequency. And I will start that by clicking now the cellular planner icon here in the middle. There we go. So now I can see all of the sites that I have been working on. And here I click the new site. And now it's creating a new site. And now it starts to guide me. The tool starts to guide me through it. So first I need to add a floor plan. And I'm adding now, I could add, ideally I would have a CAD picture, but in most of the cases, those are not available. So I actually used bitmap as a basis here. So I loaded the bitmap, and now as the first thing, I need to set the scale. So I'm saying that this is 105 meters. Okay. So now the system is detecting environment. And I'm going to come back to in a minute that what does it actually do on the background. So then the second thing that the tool asks me to do is to define the area. So the area here means that where do we want to build this network and where do we want to also set the requirements. So yeah, basically there's a tool and I use this to basically paint the area. So I'm clicking the corners and I want to build my network only to the warehouse area here. And I want to avoid then the offices and other facilities because there's no need for the private cellular network there. Okay, so now I have selected the area where I'm building the network. And now comes a really important part. So I'm clicking next here. And then the next step is to define the walls. And here we actually have an AI-based wall detection algorithm on the background that detects the locations and the sizes and the directions of the walls on the background. So as you know, it's one of the most laborious tasks in the whole design process to actually define the wall materials and their locations. And this feature eliminates that need because it detects it automatically from the picture. And as you can see, it's not perfect, but it's actually very, very good. Very close to being exactly accurate. But if you need to do small changes, you can easily do those simply by clicking and editing that floor plan. Now, here, for example, here I want to do a small modification. The algorithm has detected these shelves as dry walls, and I want to change them to be shelves because they have higher attenuation value. And you know, this is a machine learning algorithm, so more floor plans it reads, more accurate it will get. Okay, I'm happy now with the definition of the environment, so I move to the design phase. Okay, first thing, I select the requirement area and I define what kind of network I'm building. So first of all, like we discussed, I could select the IoT technologies here in a similar way, but right now we are interested in building a 4G, 5G network. Then I select the frequency band. I have some country-specific bands here, but really what I'm interested in, I want to select now the CBRS band because that's where I'm planning. The next thing I define the visualization. So what are the heat maps that the tool is going to show me first? And then the next step is that I define the requirements and discussed earlier, we define high-performance network, and accordingly, it sets now the requirements for the different KPIs. Now comes then the selection of the vendor or the access point types. So I have here a list of vendors. We have, in a similar way than in AI Pro, we have implemented the device catalog here. So I could use, for example, directional antennas to begin with, or since we had our friends from AWS in the meeting, let's use AWS private 5G radio units in this warehouse. So the location, the height is 5 meters, and now I can start placing those access points. And I place this manually, and as you can see, it's really, really fast. When I move around the access point around the floor plan, the heat map keeps updating at the same pace. I think that looks very, very nice. Now, here comes the second really important part. We wanted to combine the manual design to automated design. So I have now placed here 2 radios manually, and I'm turning on a feature called AI-assisted planning. And what it does now, it is actually taking into account my other radios and my requirements and the environment, and it's now recommending me new locations for new radios. And the added value of this, that it really takes all of this into consideration, and I can go and accept these locations one by one, or I can change them or move them around, or I can change the radio type, and it takes this into account and updates the recommendations based on that. So it's basically an AI-based assistant that helps you to combine both manual and fully automated planning. And you know, the planning or the locating of the access points is one of the most manual, tedious tasks in the design process. So fully automates that. Okay, so let's change then the heat map. We have a bunch of different heat maps here, and now we could analyze, for example, what is the signal to interference and noise ratio on the different parts of the building. It looks pretty good to me. As you can see from the legend on the left, if it would be gray, it would be bad, and more towards blue is actually good. And in this case, we don't need to care about outside radiation because we are building on a dedicated frequency. I'm looking at the data rates. So at this bandwidth that we are using, I can get somewhere around 80 to 140 megabits per second as the throughput. and I think that's sufficient for my needs. So the final check, I will select the requirement area here, and now I can check the compliancy against my original requirements. So remember, we set -80 for the RSRP and 4 dBs for the signal to interference and noise ratio, and those are now 100% fulfilled. And then one more thing. So clicking then here, I can open the bill of materials. So this automatically places all of the units that I have inserted into the design. So here we can see those 7 AWS 5G radios and their mounting brackets, but I can also manually add stuff here. So I have added, for example, Cat6 cables and PoE switches, which we will be supporting later on in our product. And as an example, I put there some security cameras as well. And then you could also insert the unit cost there if you want to have a budgetary estimate that how much would you design potentially cost. And all of this information can be also exported here simply by clicking the button on the bottom right. So that's it. I think it looks really good. And at this point, big thanks to the team. I know they've been working very hard on getting it to this stage, and I think they've done an amazing job.
Anssi, come on,
You think it
man.
looks really good?
Yeah.
You think it looks pretty good? It looks pretty freaking awesome, is what you should say. This is amazing. This is so cool.
Was I being too finish again?
You're being too finish. We need to you know, get excited about this, because this is amazing. You know, being able to design for private 5G as well, and to see it like this is, you know, awesome. So yeah, maybe less Finnish and more,
okay,
more hype, yeah,
more British. Yeah, what I loved is the supported, whatever you call the auto planner, where you place the access point and then it plans around that, and you can accept the suggestion and keep on going. This is absolutely amazing. So you have full control over it. You can accept it, you don't have to. I love it to bits. And the BOM at the end seems like an easy tool to use that can be extremely practical and awesome to have when you work on your reports.
Absolutely. That's exactly what is it used, what is used for. So can you please click next one?
Of course.
So just to recap, what did we just actually see? So our new private cellular planner is basically designed to make it easy and fast to plan private networks. And by the way, it's not only for private networks. As we saw in the demo, you can also design IoT networks using this. So we know RF and we know different frequencies, and with our capabilities and with our skills, this is also a perfect tool for designing such networks. So as you saw in the demo, the steps are the same, and it's actually the tool is guiding you through that process. So you can input your requirements, you can define your coverage areas, and then you deploy your radios or antennas into optimal locations, and it gives you exactly the right amount of radios in exactly right places. So honestly,
in the beginning, it feels like a long time ago now, because that demo was just phenomenal. But the beginning part of when you first go through that running wizard where you upload your floor plan and it takes you through all of those steps, that is really critical, and like a super helpful thing for users is making sure you actually define like the scale, your requirement areas. And then I just want to talk about that automatic detection of walls on a bitmap image, because so many of the times when I was designing for networks, when you get provided floor plans, that's the type of images you use. Yes, it would be great in an ideal world to have CAD files and or PDFs and be able to read all those layers, but realistically, that just isn't the case. So the fact that we can use our AI to automatically detect those walls and draw for you, so you can get to designing private 5G or cellular networks in our planner, that is just awesome. So, you know, there's a lot of things that is so cool about this, and that is one of them for sure.
Well, I'm glad you brought it up, because that's really part of our promise here as well. I mean, there is a complexity associated to designing private cellular networks, but our mission at Ekahau is to make it as easy and fast as possible. And many of these tedious tasks, like you pointed out, drawing the walls manually, or another tedious task or complicated task or complex task is the placement optimal amount of radios and optimal locations. And this is where we're using AI to really come up with the best possible solution in a fraction of time that it would take from you to do manually. And really our goal here is that the expertise that our users have built in designing Wi-Fi networks can really now be leveraged and go into these new emerging markets. So private cellular, 5G, CBRS, IoT design, you basically use your existing knowledge and your existing experience with the new tool, and you are able to make different kind of wireless designs.
So we don't have to get stressed as Wi-Fi professionals or Wi-Fi designers. We can just crack on with new technologies and produce amazing designs with mostly the knowledge that we already have.
Absolutely, and then you can start calling yourself wireless engineers.
But also, how amazing are those heat maps and the speed as well? It's like when you were moving that placement of that access point, the heat map updated super quick, and the heat map looks really crisp and clear to me.
It looks very nice. It looks amazing, right? That's what it is. But it also helps you in designing because the propagation model is so fast that you can see immediately how the coverage area, for example, changes when you are moving the access point. So if you have challenging structures like beams, shelves, things like that, you can see immediately how a relocation of an access point will impact that coverage area.
Yeah, it was crazy. You've got me super excited, Anssi. I cannot wait to start designing private cellular networks.
Yes, but there's probably one more thing people are asking, right? How much does it cost?
Yeah,
exactly.
This is the amazing ending to the presentation. Can you please click next? So remember, folks, this is not an official launch. We are not releasing the product yet. It is coming very soon. But how does free sound like a price?
Free sounds great to me.
So for all existing Ekahau AI Pro customers with the valid Connect subscription, or any new customer joining us before the end of the year, before December 31st, they will get Ekahau Private Cellular Planner for 12 months for free.
So if you're joining around Christmas, you not only have access to this amazing web-based planner for different wireless technologies, but you also have access to AI Pro Auto Planner with dancing APs that you can still use during the Christmas festive period.
Absolutely. Now we know what Matt will have under the tree.
Yeah, I mean, that is just amazing. Free is such a great price. You can't get better than free to start using private cellular planner tool. That is just amazing. And yeah, you're talking about not only do you get AI Pro, but access to all the mobile applications, our survey application and our analyzer application that has got an awesome new update. And I know there was a lot of people asking, when is that update going to be available? And it's coming soon. So stay tuned for you to be able to use the analyzer application with that new network view. It will be coming soon. So I can't believe how much value and how amazing all of this is now combined with our Connect package. The fact that you get, like I said, AI Pro, our mobile applications, and also this private cellular planner. I mean, honestly, my mind is blown here.
Well, sorry for blowing your mind, but this is our way of saying thank you for being our loyal customers. So we really appreciate this. And we work very hard to bring you new stuff. And this time we work very hard to bring entirely new product.
And this will definitely be appreciated. I can't wait to start using the product. Thank you very much, Anssi. Thank you very much to the product team and everyone that was involved in creating that smashing tool.
Thank you. I will make sure they get the feedback.
Yeah, super amazing. And yeah, I just want to say a huge thank you to you, Anssi. That was a great presentation, amazing demo. I can see so many people are just crazy excited about this, and just as much as what me and Mac are, we cannot wait, and they cannot wait to start, designing private cellular networks with this amazing new tool. I just think back to over, 2022, since me and Mac have joined Ekahau, we've launched AI Pro, Sidekick 2, and now we're teasing out private cellular. This has been one heck of a year, and we cannot believe how amazing all of these updates are. But what fantastic clients we have. We wouldn't be here without all of you amazing Ekahau users and joining us on today for the Wi-Fi day. So thank you so much for being here, and I want to say A huge, massive thank you to all of our speakers.